Most X-rays are created by machines, and their penetrating power depends on the voltage of electricity used to produce them. The higher the voltage, the greater the penetration. Gamma rays are given off naturally as certain kinds of elements decay or break down. Uranium is the best known of about 50 elements of this type that are naturally radioactive. A special type of radiation energy that we hear more and more about today is laser energy. Unlike the light from a flashlight, which diffuses as it travels farther from the bulb, the amplified light of the laser beam maintains its dimensions at every point along its path, with no loss of energy at any point. Laser rays or beams are used in surgery, communications, and other applications. While a laser beam itself does not contain high-energy radiation, the beam can be concentrated to such a point that very high levels of heat are produced and may present the potential for serious eye damage if viewed directly, or burns if the skin is exposed. Serious eye damage can also occur as a result of laser beams being scattered off shiny or polished surfaces. We've mentioned that high-energy radiation is produced naturally by some radioactive elements such as uranium. This type of radiation can also be produced artificially by such devices as X-ray machines and high-energy accelerators found in hospitals and research labs. These high-energy waves pose a potential hazard since they have the ability to penetrate into and through matter. Because this high energy can actually enter and pass through the body, potentially damaging cells and altering atoms within, great caution must be used whenever such energy sources are present.
Working safely in the laboratory is an important job, but it isn't difficult if you follow the rules. Be aware of the hazards around you. Read container labels, review material safety data sheets, and consult your facility's chemical hygiene plan. Take steps to minimize the dangers. Wear the appropriate personal protective equipment, use safe work practices, and be prepared for emergencies before they happen. The laboratory is no place for guesswork. If you have questions, ask your supervisor or your chemical hygiene officer.